In this lesson we'll be discussing temperature. In this class we'll denote temperature with a capital T. Temperature is an intensive property, so if you're looking at the system of your, say, the air in your room, where your fluid in that situation is air, you take the temperature of the air in that room. If you were then to divide the room you're in half, the temperature would not change. So temperature is not dependent on the mass of the system, therefore it is an intensive property. Now, temperature is defined as a measure of hotness or coldness. So it is in this class we'll look at the hotness or coldness of different fluids, both gas and liquid. There are two basic scales used in the world. There's the English system, which many are familiar with, and there is the SI system, which stands for Scientific International. It's French, so actually it would be International System, or International Scientific for us. We just call it SI for short. And there are two types for each of these. There's the common system and the absolute. The common system was developed first, and the absolute was developed later by those who saw a need in thermodynamics. So the common system in English is the Fahrenheit. Was developed by Daniel Fahrenheit in 1724. He was also the guy who invented the mercury thermometer. It's based on some very arbitrary things. It's based on 0 degrees Fahrenheit being a mix of water, ice, and ammonium chloride. 32 degrees Fahrenheit is when ice first forms on water. 96 degrees Fahrenheit was supposed to be the temperature of the human body. So it's a system we use, but in terms of thermodynamics, it doesn't have a very good baseline for us to use. The SI units system was developed by Anders Celsius in 1742. It's a little better. It's based on one fluid, which would be water. Though originally backwards, it had boiling at 0 degrees Celsius and melting at 100 degrees, which we were flipped around. It at least stuck to one substance, just water, and had some very easy numbers, 0 for freezing, 100 for boiling. But in terms of thermodynamics, we needed more. So Lord Kelvin, in 1848, developed his system, and his is based, in the absolutes type, is based on the absolute 0 temperature. So it is supposed to be theoretically the coldest temperature you can ever get a fluid. So he was based it on Celsius, but determined what the lowest temperature in Celsius could be and said that is 0. And so in Kelvin terms, that will be 0 degrees Kelvin, the absolute 0 temperature. A fellow scientist at the University of Glasgow in 1859, William Rankine, he developed the Rankine scale, which is similar. It's just based on the Fahrenheit system. So also uses absolute 0 as the lowest temperature, but it's based on the Fahrenheit. So what this means in relation, if we relate these together, the common to absolute, we can look at the temperature in Kelvin is going to equal the temperature in Celsius plus 273.15. Okay. So your Kelvin temperature should always be higher than your Celsius temperature for a reading. You can never get a negative absolute temperature because the lowest in absolute temperature goes 0. So the lowest value you could ever get in Kelvin would be 0. The relationship for Rankine to Fahrenheit is just going to be temperature in Rankine is equal to the temperature in degrees Fahrenheit plus 459.67. These equations are located in your textbook as equation 1.6 and 1.7.